In section 5.5, we're going to talk about the rational root theorem. Basically, what the rational root theorem is that it gives you a way to determine the possible roots of any polynomial equation, p of x, when it equals 0. So we've learned how to do this by doing the quadratic formula, by factoring, by graphing. The rational root theorem just basically gives you a pool of all of the possible numbers that you could find your roots from. If the coefficients of p of x are all integers, then every root of the equation can be written in the form p over q. P stands for all of the factors of the constant term of your equation, and q stands for all of the factors of the leading coefficient. Taking a look at an example, here I want to find the rational roots of p of x equals 2x cubed minus x squared plus 2x plus 5 when it equals 0. So here I'm going to take a look at the leading coefficient and constant term of this equation to find my pool of possible roots. My leading coefficient, or my constant term, is 5. So all the factors of 5 are positive and negative 1 and positive and negative 5. My leading coefficient is 2, and all of the factors of 2 are positive and negative 1 and positive and negative 2. So using these numbers, I'm going to find all possible p over q values, and that's going to be all of my possible rational roots. So possible roots could be positive or negative 1 over 1, so I could have a root at negative 1 or positive 1. I could have a root at positive or negative 1 over 2, giving me possible roots at negative 1/2 or positive 1/2. I could have roots at positive or negative 5 over 1. And finally, I could also have roots at positive and negative 5 over 2. So here are all of my possible roots. If I have any rational roots, it's going to come from this pool of numbers. So in class, you'll have a table, and what you're going to want to do is plug these numbers in or use synthetic division to figure out which ones would be roots of the equation. So looking at our table here, here's all our possible roots written out. If I find the values of all of these, I would find that the only x value that gives me 0 is negative 1. So from here, I can conclude that the only rational root is negative 1. The last thing that we're going to talk about in this video is the conjugate root theorem. If p of x is a polynomial with rational coefficients, then irrational roots that have the form a plus square root of b and imaginary roots come in conjugate pairs. So basically what this is saying is that if you have a root at a plus square root of b, then its conjugate a minus square root of b is also a root. Similarly with imaginary numbers, if a plus bi is a root, then a minus bi is also a root. You might have already picked up on this when we do the quadratic formula, and you could have like a plus or minus b over 2a. So for an example, let's say you have a quartic polynomial that has rational coefficients. We already know that we have a root at positive square root of 2 and 1 plus I. And just using that information, I'm able to determine what the other two roots have to be. I have positive square root of 2 and 1 plus I. The conjugate of positive square root of 2 is negative square root of 2. So I can determine that that's also a root. Also, if 1 plus I is a root, its conjugate pair, 1 minus I, also has to be a root.